Problem 5. Determine the total charge transferred over the time interval 0 to 10 when current is 1/2 times t amps. So total charge transferred, yeah, so if you already did question 3, find the charge flowing through a device if the current is this. You've already done this. It's an integral. Now we could do it. You see over here some of these graphs, but we know what those are. Those are later though. So we'll just do integral since we've already done that. Write down this information here. So we have t, this is problem 5. So t is from 0 to 10, and current is t by 2, and that's amps. Okay. I really don't like this kind of, the current is amps, and so then time has units of seconds, which means this 1/2 has units of what? So amps needs to equal coulombs per second, but you also have amps equals something times seconds, which means the 1/2 has units of coulombs per second squared. It's just weird to think about that the 1/2 has units. I don't like it, but anyway, there's not a lot I can do about it. We'll just try to ignore it. Okay, so what are we gonna do? That's also why you should just make sure that all the units are in your standard SI units and whatever you need them to be in, so that we don't have to worry about it. Okay, so we want to do the integral. So we know that I, that's the current, is equal to dq by dt. So we can solve this for dq equals I times dt. If we integrate both sides from some, I guess we'll do 0 to 10. Why not? We have that there. So from 0 to 10, then we have q at 10 minus q at 0 equals, oh, this shouldn't be 10, this should be 0. 0 to 10, not 10 to 10, that would be 0. And then we just have integral from 0 to 10 of t over 2 dt. Okie doke. This one will be, take the 1/2 out, and then it would just be t 1/2 0 to 10 t dt. 1/2 inside there, you get 1/2 t squared, right? 1/2 t squared, and you can check because derivative of this, we get rid of the 1/2 and you'd have t. And then that's from 0 to 10. So this is 1/4. And you can still see. T squared, that'll be 100 when you put the 10 in, and then 0 when you put the 0 in. So it's this, and that is 25. On this side, we have this and this. So we don't know either of those. The question, though, was determine the total charge transferred, which can mean the change in it. And this is also the change in it, the total change in it. Remember that when you do an integral, this dq is the change in q. So when you integrate, you're summing, you're adding up all the little changes that have happened in dq all the way from 0 to 10. And that's just the total change that has happened in q. So this is just delta q. So the answer is 25, and presumably it'll be coulombs. Presumably it's coulombs. So there you go.